Now let us look at the solutions to exercise 3. 1. I. A union B L complement. It is equal to elements which belong to neither A nor B. It means that the members for this set, which is A union B L complement, cannot be found in both set A and set B, but can be seen in only the universal set, which is the mother set, by which A and B are a subset of II. A intersection B complement. It is also equal to elements which belong to A only, and we can find these members by subtracting the intersection members or the number of intersection elements from set A, and the remaining members or the remaining number of items in set A becomes our A only. The last question for question 1. A complement intersection B. This is also equal to elements which belong to B only. It means that we cannot see these members in set A, but it is found in only B. We also find this number of members by subtracting the intersection from set B, and the remaining number of items or the remaining number of members becomes our B only. So from this, you can see that the set which the complements are not written with becomes the set which that particular number of members belong to. Again, from these operations on the sets given, we can identify that the set which the complements are not written with, that particular set becomes the set which that number of elements belong to. So we can see that for II, the complement is written with B, so the elements belong to A only. III, the complement is also written with set A. Therefore, the members belong to B only. Let us look at some identities for intersection as operations on set. And also union. For I, B union A complement is equal to elements which belong to neither A nor B. B complement intersection A is also equal to elements which belong to A only. I. B intersection A complement is equal to elements which belong to B only. So when we compare this set in our question 1, I, and I with the notes given here, we can see that when we interchange the positions of the two sets using the same operation, which is the union and the intersection for this complement, we can see that we have the same result. So for question I under question 1, the first set was A and the second set was B. And when we interchange this position whereby we brings B to become the first set and A to become the second set, using the same operation union, we have the same result. And also for II, the first set given in the question was A and the second set was B. And when we interchange this position to bringing the first set as B prime and the second set as A, we also have the same result. Therefore, we can say that intersection and union of two sets and the complements are commutative. It means that whenever we interchange this position of the two sets, we are going to have the same answer. Now let's come to question 2. A. A set was given to us and we are asked to represent this set on a Venn diagram. So in our question, we have only science, which is S, equal to 10 students, only mathematics, M, equal to 15 students, number of S intersection M, which is the same as both science and mathematics, is also equal to 5 students. Neither science nor mathematics, which is student who does not belong to both science and mathematics, is equal to 3 students. So to represent this on a Venn diagram, we draw a Venn diagram. After that, we represent the intersection portion of the Venn diagram first, and the intersection number of members is 5 in our question. So now we can represent the other portions, but the science was given to us before the other sets. So we have to come to the science portion before we go to the other portions. And only science is equal to 10 students. The phrase only science or the word only attached to the science, it means that we are going to put this number of members in the science circle. That's the remaining part after putting the intersection members. And we put this number of members without subtracting or adding the intersection because of the phrase only science or the word only attached to the sentence for this number of members. So whenever the word only is attached to a sentence, that particular number of members for that sentence, we put it within the circle of that particular set. And you also don't subtract nor add the intersection members from it before putting this number of members within the circle of the remaining parts of the set. So we also have only mathematics to be 15. Since the phrase only mathematics or the word only, we are also going to put this 15 verbatim on the remaining portion of the mass without subtracting nor adding the intersection members because of the phrase only mathematics or the word only attached to this sentence of the number of members. So whenever the only word is with a sentence, that particular number of members given in the sentence, we don't subtract nor add the intersection members from this. And we also put it within the circle under the name of that particular set, which is the remaining part of the set after representing the intersection set. Now, we also have neither science nor mathematics, and this is also equal to 3 students. So, since it is neither science nor mathematics, it means that this number of members doesn't belong to any of the two sets. So, it must be outside the two circle, but supposed to be within the rectangle to show that this number of members belong to the universal set but does not belong to both of the two sets given. So the important thing here you have to note is whenever the word only is attached to a sentence or a statement, that number of particular sentence in which the only has been used with, we don't add nor subtract the intersection from it, and we also put this number of members within the circle, which is the remaining parts after representing the intersection number of members. Now let's come to the B. I, which is number of S, and it's the same as number of science students. And it means that everything that we can see from the blue circle belongs to science. So we add 10 and 5. And this has been given as 15 students, as we can see from the diagram for the blue circle. So we also have number of mathematics, which has been given as number of M. It is also everything that you can see in the black circle, which is 5 and 15. So we add this number of members in the black circle, which is 5 plus 15, and it is also equal to 20 students. Now, the number of U, which is the total number of students, is also equal to everything that we can see in the rectangle. So we add 10 plus 5 plus 15 and plus 3. This is also equal to 33 students. So the difference between only science and science, only maths and maths, is that whenever only is attached to a sentence or a statement, we write its number of members within the circle, which is the remaining part after representing the intersection members, while we don't add nor subtract the intersection members from this number of members when only is attached to its statement or its sentence. And whenever we hear maths, science, English without the word only, we put this number of members on top of the circle for that particular set. This video presentation is from EDLE, Special Mathematics Classroom, and it was presented by Sir Nicholas Nkansa, student at Kibi Presbyterian College of Education, doing Bachelor of Education degree program in ICT and Mathematics. You can subscribe to our YouTube channel for more video updates. Thank you for watching.